Alrighty, Mr. Gatekeeper here. I got Mr. Little Rascals. It's called a I don't know if you can see that or not. That ain't showing up real well. A sugar SC Sugar Charlie 100 Tango bilinear, SC-100T bilinear, on these old school 2-pill amplifiers with the stud mount design. And I will have to say this is one of the more sophisticated ones that I've seen in this type of model. And you can tell this bad boy is old. We're talking about over 30 years old. And basically the guy sent it up here to me because he said he's having some problems with the transmit, the preamp, basically the whole circuit right here. And I pretty much have already could tell that. It's pretty cool. They got an invert circuit on the preamp utilized with it now, but it's causing issues. And I've seen this in the past. This is like the absolute cheapest possible form of a output filter circuit, wide banded. This is supposed to be about the easiest, cheapest way to make an amplifier work on the whole HF spectrum. But you know, the proper way to do it is to have separate filters for each band. I'm going to go ahead and remove this out. This guy's just going to be running this on a very narrow frequency range. But and the other issue he was having is it was dead keying too high and wasn't swinging, which I can demonstrate here. We've got a 250 watt slug here. Okay, so that means we're looking at the top scale on the meter. Now, I'm just putting a 1 watt dead key into this. See it dead keying about 90 watts? So that 10 is 100. Now watch this. Oh, it's swinging backwards. If you take a look at the input reflect, it's the 5 watt slug. Oh, she's swinging up almost to a watt. Oh, almost to 1 watt of input reflect, and that is definitely not acceptable for two 455s by no means. So I'm gonna get here and do a little bit of work. I'm going to remove this board right here. I'm not even going to attempt to repair this board at this point. Cost wise and time wise, it's just going to be a lot easier and cheaper for me to remove this board and just drop 2 relays in here myself and hook everything up. I'm going to draw a quick diagram of how the amp's laid out. I'm going to take this out of line too as well. I'm also going to retune the amplifier and get these trimmers out of line and put some fixed capacitors in, which is what I normally do anyway. This is an amp from back in the old days where you had positive grounded vehicles. That's why you see all these caps right here, which is isolating the board's ground from the frame and the heatsink, which means that this amplifier is not using the frame and the heatsink as a DC ground. So right now all it's relying on is the board's ground and the wire going out, and it is a lot more efficient for an amplifier like this to use the frame and the heatsink as a DC ground, as well as using the heatsink as heat dissipation, of course. It's a lot better to have that more extra ground, make it a lot less possibility of a lot less noisier, and it'll actually stay a little cooler in some instances too, since it has more of a ground plane to work off of. So I'll go ahead and do the modern day conversions, I like to call them, and take these out right here and basically put a piece of a jumper between all these points to make sure that the board is grounded to the frame's grounded to the heat sink. So we'll have one good solid ground. We're going to do a power wire upgrade too, and put a nice strain relief in there for them, and throw an Anderson connector on there. And we'll do a couple other things too. I'm going to take this 820 off, put a little bit more heftier 820. It's not really needed, but make me feel better, go a little overkill. And I think I'm probably going to also take this right here off, which is power's coming in right here, is flowing up under the transformer to right here, then feeding the back of the transformer to give the transistors B plus or DC power. I think I'm just going to run a jumper with heavier gauge wire from here to the back of the transformer, and we'll get this thing tuned out. And also I need to retune and probably put some attenuation on here. I wish I had some room to put maybe a high-low switch on here for you, bud. I mean, I could probably squeeze one right here, but we're just going to try to get this thing probably just tuned down to where you wanted it, which was at a 20 to 25 watt dead key. Let's see. Okay, 2 watt dead key. You got 2 watts going in. It'd be cool just put a variable on this thing so you can dial it in yourself, you know. But I ain't gonna try to get anything, spend more time than I need to in it. But if I could get it right there around that point and throw a variable on it, you could sit there and dial it in exactly where you want it. But we ain't got a lot of room to work with that. I'd probably have to, I mean, I know how I could make it work. Had to remove this LED right here and re-put it somewhere, and basically move this switch down here. I made but see, then you got the little issue too, because they're labeled. But I could relabel them. But you know, well, I'll just kind of go with the flow, see how it works out, see how my little you know, modifier, little 2 angels on each of my shoulder. You know, this angel says do this, and this one says do this. I'll just go with the flow in here and listen to the voices. No, I'm just kidding. I'll just kind of go with it and see what happens, man. So, and go with the flow. We'll figure it out for you, bud, and achieve what you're wanting. So I'll be back with this bad boy finished. Hey, big brother. No gatekeeper back, man. You ain't gonna believe this, man. Just simply after doing the modifications, meaning removing the amp board. And by the way, I believe that this device right here, I believe had went bad. But guess what? I searched Google up and down every possible which way, and I can't even figure out what device that is. It's got 4 legs to it. I would only be guessing. These 2 right here are general purpose transistors. One's for your keying circuit, one's the amplifier for your preamp, I'm pretty sure. But this right here, it says Motorola SFE
in September. He actually withheld funding for what's called the global
1329, and it says 724, I believe. 724. I could find absolutely nothing. I tried every combination possible, so I made the right choice anyway to go ahead and remove this amp board, because this amp's so old, man. Even some of the electrolytics, you know, are probably getting close to being bad, or anyway. And just simply doing that and manually putting in the boards and a new preamp and everything, your input reflect dropped dramatically, and your output pretty much doubled, man. Doubled. At this point, you really cannot even call this a 100, whatever it was, 100 anymore. This thing's operating like 455 should be doing. Take a look. Take a look. We're on 13. I think my batteries done went dead. There we go. 13.8 volts. 13.8 volts. Alright, this is a 250 watt slug. Alright, this is PEP. PEP, we're looking at the top scale. The 10 is 100. Watch this. Oh. 220 watts. And look at this. If we turn the voltage up to like what a vehicle would be, 14.5 or so. Now take a look at this. Oh, pretty much right at 250 watts. This thing has doubled in output. Now let's take a look at the input reflect. You saw where it was before. Very, very, very low. Very, very low and acceptable. So I retuned the input. The output did not need to be retuned at all. It was right where it needed to be. So here's the fixed capacitor for your output right there. And instead of putting your fixed capacitor for your input here and stretch it all the way over, I modified the board down here so I could have a ground right beside there for the keying circuit. And the input tuning cap is right down there. So went ahead and did the let me turn this supply off here so I can point in here and show you. These are all the caps and everything that was the blocking caps or whatever, keeping the frame and heat sink from the ground. And see, that's another thing that you've got 2 or 3 things here that could have helped this thing come up in power. And so here's the jumpers right here. It's connecting the frame to the ground plane of the board right here. And then you got one down here that's right here that's connecting both SO239s to the ground plane of the board as well. This is the small cap right here that was only a 300 volt cap. It was on the output. Went ahead and replaced that with a big whopping DM19 500 volt cap. That thing will last from here to when we start living on Mars, man. And I went ahead and did your power wire upgrade. This is some real good thick 10 gauge wire. What was in there was some 12 gauge, and the fuse holder was sitting there cracking. And that's again, if you do want to put a fuse on this thing, just all you need is a fuse right there at the power source. If you're going to be running this in a mobile, just have a fuse right there at the battery. Other than that, if you're running a power supply that's protected with reverse polarity, etc., then you're fine. You don't need a fuse. But you know, I'm never going to tell somebody not to use a fuse. Of course, the more protection, the better. This is the choke that was sending the power, the DC power to your transistors. That wasn't even using Teflon wire. This is, I believe, 20 gauge or 22 gauge. Went ahead and replaced that with some good thick 16 gauge right here, instead of being soldered over here. So the power has to travel over here before it even hits the choke, the power to transistors. It's soldered directly on the power wire coming in, and soldered up there in the back, the power to transistors. And I went ahead and added 2 feedback circuits as well. This right here just helps a little bit of neutralization. It kind of helps the amplifier become more stable, especially across a wide bandwidth of frequencies. So here's your preamp right here. Now your preamp is set up to run only when the amplifier is on. So when the amp's on like this, they've got everything backwards where you press down. That's preamp on, preamp off. SSB delay on, SSB delay off, AM. Alright, so the only thing I have not done is set up the input attenuation. So check this out. I'm talking about I did absolutely nothing before retuning and anything. The input dead key, remember it was around 100 watts, I believe it was, or 80 or so. It dropped half that just after doing this modification, still leaving the trimmers in. It's crazy, huh? So anyway, here's your dead key now, putting a 1 watt dead key into it. Top scale, so putting a 1 watt dead key into it is giving us right there about 25 watts. But I know that you wanted about 25 watts of dead key with 2 watts going into it. So now what I'm going to go ahead and do real quick is turn my radio's dead carrier up to 2 watts and then go ahead and make some adjustments, and I'm going to drop that resistor right here. Just a little bit of attenuation to drop that dead key to about 20-25 watts with a 2 watt dead key going in. So I'll be right back. Alright, brother. I got it. Alright, here's where my dead key is at on my radio. 5 watt slug. Looking at the middle scale, where you see the 20 at 2 watts. So it's just a tad bit under 2 watts, just a tad bit under. Well, that's because the amp is on. When the amp is off, it's exactly at 2 watts. The radio falls back just a tad bit. So here is the attenuation right here. All right, turn this back to and show you your input reflect drops, of course, since now you got some resistance right there. 250 watt slug. All right, we're going to look at the dead key, of course. We're looking at the top scale. So where you see the 50, it's 50 watts. The 100 is 100 watts, and in between 50 and 0 is 25 watts. So here we go. Look at that, just a tad bit over 25 watts. Which was right there around the same range that you wanted it. I could sit there and turn my dead key back just a tad bit, or let's see. Actually, I got the voltage up a little bit. Let me turn the voltage back down to where I had it originally. Now let's take a look at it. It didn't make much of a change. So that's right there within the same, right there within the range that you were wanting. That's just about 5 watts more, which is pretty good if you ask me. Get this dang thing to focus. All right. Oh dear. Oh dear. So that's how much it's doing RMS. You got your peak. Oh, still hitting about 200 watts peak, man. So I'm gonna go ahead and put your Anderson connector on now, and that'll be it, man. I think I'll go wash your top for you, get a little clean, and put your screws on it and get it out to you. That's a little diagram right there I drew for myself. Whenever I do something like this, it's best for me to take, 20 to 30 minutes to just draw me out a diagram, because Mr. Gatekeeper has a negative that some other people may not have, and it's called terrible short-term memory. I was born with it. They tested me for ADD back in school and said, nah, he don't have ADD, but he's got a short-term memory issue. So, yeah, back when I was high school dancing with Mary Jane, it only got 10 times worse, if you know what I'm saying. But I had to divorce old Jane, Mary Jane. She was giving me panic attacks back in the days, so hadn't danced with the old Jane there since I was in high school. But got her done for you, man. There's no amp too small for me to work on, and I would say there's no amp too big, but what limits me with how big is how much power supply I have. So really right now at this present moment, probably the biggest amp I probably could work on would be probably a 24 pill. Turned out great, man. Did a lot of little work on this small amp. Alright, bud, go ahead and get your Andersons on, get this top on, get this thing back out to you, man. Hope it lasts a long time. Enjoy. Old Gatekeeper, northeast end of Georgia. Bye.